Area of simple figures. So we're going to be looking at the simple area formulas for these shapes. So for a square, first of all, this is not a square, but for a square, the idea is that a single square that's 1 by 1 has an area of 1. And if you look at larger squares, you can, if they have integer side lengths, you can count the boxes and say a 2 by 2 is 1, 2, 3, 4. Or if we look at this 3 by 3, that it's 9. In general, what we would say is that it's the side length times the side length. In other words, the side length squared is the area for a square. For a rectangle, there are 9 for each row, and there are 3 rows, so if we add those up, we'll have 9 plus 9 plus 9, or 3 times 9 is 27. And in general, that's base times height. You could say that it's length times width. That's also fine. The important thing here is that base and height must be perpendicular. So the base and the height must be perpendicular in order for them to be your base and height of a rectangle. In a parallelogram, a parallelogram can be related back to a rectangle because in a parallelogram we can slide these and see that here the rectangle is base times height, but if I slide it to make it a parallelogram, this triangle on the left has the same area as the triangle on the right. So this will still be base times height. However, it's important to know that the base and height must be perpendicular to each other. So you would be using that height and that base. We are not using the slanted sides. If you wanted to use this slanted side, you could, as long as you use the height that is perpendicular to it. So you could multiply the 2 red lengths together, you could multiply the 2 blue lengths together. Typically we'll multiply the 2 red lengths together, but either way, you can't multiply the sides unless those sides are perpendicular. A triangle. A triangle is half of a parallelogram, and I can show you that generally by rotating it around the midpoint of one of its sides. That gives us a parallelogram. So for the parallelogram, we already knew it was base times height, but we're talking, this is 2 triangles, so 1/2 of the parallelogram's area will be the triangle's area. For a kite, we can do the same thing. If we rotate this around here, etc., we get that each of the triangles are doubled. Those are the same triangle. These are congruent triangles. These are congruent triangles. These are congruent triangles. And because of that, we can say that the whole area is going to be the area of the rectangle, where this is one of the sides, that's the other side, which are the diagonal 1 and diagonal 2. So diagonal 1 times diagonal 2 would be the whole thing, but since we doubled it, we have to cut it in half to get half of the product of the diagonals. For a trapezoid, we have the height is perpendicular to the 2 bases, and we will average the bases and multiply by the height. Essentially, you can think about this as finding the midpoint of each lateral side and pretending that that triangle gets rotated around that point to make a congruent triangle, and you'll get the trapezoid. And lastly, a circle. We've gone through this before. Pi r squared is the area of a circle. So an example of how we would use this is that the area is 1/2 sum of the bases times the height. So we would say that the bases must be parallel to each other, 4.9 and 11.9, and the height is 6.7. Now we want to simplify this. which becomes 16.8 times 6.7. So 8.4 times 6.7. 8.4 times 6.7 is 48, 50, 8265. So is 56.28. And also, the units for area are not miles, but square miles or square feet or square inches. And we typically will indicate it like that or with SQ and then MI to say square miles. I'll accept either one. So let's fill this in again. The formulas were S squared, base times height, 1/2 base times height, half of the first diagonal times the second diagonal, the average of the bases times the height, and pi r squared. Those are your simple area formulas.